Teleportation is the theoretical transfer of matter or energy from one point to another without traversing the physical space between them. Well, it is a common subject in science fiction literature, but in the future will be a very useful thing. Now, in some situations, teleporting is time across space. Is teleportation a science fact or a science fiction? Quantum teleportation is a real thing, but what exactly is it? It is the transportation at light speed of quantum information. No matter. I know that sounds boring, and I mean we transport information at light speed all the time with wireless, unwired, and communications. But here is the thing, quantum information is special. It is so special that it produces many strange things. It means probabilities that can do subtract daylight choice quantum eraser, quantum computing speedups, interaction, free measurement, entanglement, and a lot of more stuff, all of which in some ways defy our intuition or how space and time should or appear everyday perception to behave. Quantum information, odds behavior also makes the entire created universe the marvelous place it is. Every atom cannot behave as it does if not for superposition, if not for the odd dance of entanglement and the associated mysterious exchange of quantum information. There is an emerging consensus amongst physics that loosely put information, in a real sense, more fundamental than matter. So, if you sent quantum information and used it to resemble the original object, it not be the original object, that would be a very good answer in the future. None of the technologies alone provide a perfect solution. So, the scientists say a hybridization of the various protocols and underlying structures offer the most truthful approach. For instance, systems using photonic qubits work over distances up to 143 kilometers, but are the probabilistic in that only 50% of the information can be transported. So, to resolve this, such a photon system may be used in conjunction with continuous variable systems, which are 100% effective but currently limited to short distances. So it means that you can only will teleport to a short distance place. So now we'll explain how it is supposed to work or how it will be supposed to work in the future. So now, to clone an hydrogen atom, you will need a proton and an electron. Okay, so we have the letter A. An hydrogen atom is a superposition of three quantum numbers: proton spin, electron spin, and energy level. Okay, so if we knew beforehand that only two energy states of the hydrogen atom were possible, let's say that the atom was called an isolate. This is through experiment. Don't get upset if this isn't realistic. So, in other words, we will need 3 qubits to describe the superposition. So now, describe the math, and it means that we will describe this from the mathematics side. So we got here something that a scientist wrote, and he wrote, I will use standard bracket notation. I will also use the term NOT, short for the operation applied to, called the control NOT. This is an operation that reverses the second bit if and only if the first bit is 1. It is a frequent feature in the quantum computing. And what engineering needed to teleport a hydrogen atom with 3 quantum numbers? Well, we will require 3 entangling qubits. So we keep 3 and we send 3 paired particles, probably by fiber or free space. To measure the initial hydrogen atom we seek to teleport, we need to entangle photons to copy the quantum information of the hydrogen atom. In doing so, the no-cloning theorem says that the original atom must decohere. Quantum teleportation of a human. Okay, so what we most likely infeasible, will it be any different than real material teleportation? No, at least not as we understand physics today.